Hi, hello, good evening, one and all. Welcome to the session. Can anybody confirm about audio and video? Please do let me know about audio and video, and do let me know your presence so that we can start the session. Please do join in and try to share this session with your friends also, so that we'll move on. Let me check from my end also, so that if everything is good, then that's fine. Can anybody confirm about audio and video? Hi, hello. So in this session, we are going to discuss about the reasons behind nodal and mesh techniques. Okay, so please do join in, guys, and try to share this session with your friends so that let us make this session very beautiful. Okay, right. So as I said, so this session is all about reasons behind the nodal and mesh techniques. Okay. Before moving on to the nodal and mesh techniques, or if you want to know the reasons behind nodal and mesh technique, so I just wanted to tell you before nodal and mesh analysis or before nodal and mesh techniques, there are few other techniques also to solve the network. Okay, so let us solve them. Let us solve them, and so that we will try to from that we will try to understand the reason behind the nodal and mesh techniques. Okay, so let us move on. So before moving on to the session, there is a small introduction about myself. My name is Naveen Kollapalli. I have around 11 plus years of experience in teaching. Most of the times I'll be teaching circuits, machines, measurements, and power system. Okay, so there's a small introduction about myself. Moving on, so let us get let us start the session. As I already said, before moving on to the reason behind mesh and nodal technique, I just wanted to tell you the basic things. If you want to solve any network, you need to apply KCL as well as KVL, or otherwise current division rule or voltage division rule. So these are some laws and rules. These are some laws and rules you need to apply if you want to solve any network. Okay, right. So let us do this problem by applying KCL or KVL according to the question. He's asking a question, find the currents I1, I3, I4 and I5 for the circuit shown in figure below. Here is the circuit is given like this. The circuit is given like this. So the current is entering 15 amperes current is entering at this junction, and out of that 15 amperes 6 amperes is leaving through this R3. Okay, now that 6 amperes will definitely tries to flow through this path, and of course remaining out of 15 amperes 6 amperes is flowing like this, and remaining current will definitely flow through R1 and R2 and comes out of the junction D. Okay, now what is asking? He's asking the current values. He's asking current values I1, I3, I4, I5. Can anybody tell me the values of current? Can anybody tell me values of currents? I1, if you apply KCL at the junction A, KCL at junction A or at node A, if you apply, then I can say I1 is going to be 15 minus 6, we will get it as 9 amperes. What will be I3? I2 is anyhow 6 amperes. What will be I3? I3 is the current which is flowing through resistance R2. Whatever the current which is entering at junction B, the same current will leave. the same current will leave. So I can say I3 is equals to I1, that is 9 amperes. Now can you tell me about I4? Can you tell me about I4? I4 is a current which is leaving from C junction or simple node, I can say. And this, what is the current which is entering at C simple node? 6 amperes, that is I2. So whatever the current which is entering at C node has to leave from C node. So I can say I4 is equals to I2, and that will be equal to 6 amperes. Now the next current is going to be I5. I5 is the current which is leaving from junction T. I5, which is the current which is leaving from junction T. Okay. I'm sorry. Just a minute. So I5, if you take up I5, I5 is equals to I4 plus I3. I4 is going to be 6 amperes and I3 is going to be 9 amperes. You will get it as 15 amperes. Or simply, whatever the current which is entering at this side, the same current has to leave from this side. That is what KCL, right? Whatever the amount of current which is entering into any particular, any junction or any network, the same current has to come back again. Okay, so these are the current values. Now what I wanted to say is at this point, here, to solve this kind of network, no need to apply nodal analysis, mesh analysis. A basic KCL is enough. KCL is enough. Okay, let me show you one more network here. He is asking, by using KVL, find the voltage V1, V2 as shown in the figure. Let us not mention this one. So find the voltage V1, V2 as shown in the figure. So if you look at the diagram, V1 is here, V2 is here. If you want to find out V1, let us apply KVL and always try to apply KVL through the minimum number of closed path. Minimum number of elements closed path. Or you need to apply the KVL in a closed path where minimum elements should be existed. So if you are writing KVL in this one, so plus V1, and here there is no element, and here we have got an element, that is a voltage source. So that is plus V1 plus 15 is equals to 0. Plus V1 plus 15 is equals to 0. So if I write plus V1 plus 15 is equal to 0, and I will get V1 is equals to minus 15 volts. Now can you tell me about V2 value in the same way? Can you tell me about V2 value in the same way? So if you take up KVL, plus V2 plus 40 and minus 20 is equals to 0. So plus V2 plus 40 plus minus 20 is equals to 0. So I'll get V2 is equals to minus 20 volts. So these are the voltages in this given circuit. So to solve this circuit, a simple KVL is enough. To solve this circuit, a KVL is enough. Okay. In the previous network, we just applied only KCL. In this network, we just applied KVL. So these are the basic laws. Let us see one more network. Here, this is the network. Find all the currents and voltages of the network shown in the figure below. So the network is given with some multiple resistors and a voltage source, and is asking all the currents and voltages. Okay, so if you want to find out current or total current, I, so you need to calculate first of all total resistance. Yes or no? So the total resistance will be, try to reduce the network from right to left, because the source is on the left side, so try to reduce the network from right to left. Okay, so it will be 3 plus 1, it will be 4, and here 5 and 5 are in parallel, so the equivalent will be 2.5 ohms, and here this equivalent will be 4 ohms. Now 2.5 ohms and 4 ohms are in parallel, and that will be in series with that will be in series with 4. So I can write RT is equals to 4 plus 2.5 into 4 divided by 2.5 plus 4, it will be 6.5. So if I solve this now, this one, I'll get it as 2.5 into 4 divided by 6.5 plus 4. I am getting it as around 5.53. This is the total resistance, so that I can calculate easily current. Current I is equals to E divided by total resistance RT. 20 divided by 5.53, you will get it as less than 4. So if I solve 20 divided by 5.53, I am getting it as around 3.6 amperes. If 3.6 amperes is flowing through this resistor, now 3.6 into 4, 3.6 into 4, more than 12 volts, that is around 14.4 volts drop. So this 3.6 amperes is entering at this junction, and the current will divide here, IA and IB. So if you want to find out IA, entering current is 3.6, opposite resistance is 4, 4 divided by 4 plus 2.5. Yes or no? So 4 divided by 4 divided by 6.5. 4 divided by 6.5 into 3.6. I am getting it as around 2.21. So IA is 2.21. So if IA is 2.21, what is IB? IB is simply 3.6 minus 2.21. 3.6 minus 2.21. So I am getting it as around 1.39. So once you get these currents, use it current into resistance, you will get the voltage. So V4 will be here 1.39 volts. 1.39 into 3, 1.39 into 3, you will get it as 4.17. V5 will be 4.17. If you want to solve the current flowing through this 5 ohm resistance, this 5 ohm resistance, as the resistors are equal, current will be divided equally. So it will be 1.10 or 1.1. Let us take up it as approximately 1.1. So 1.1 into 5, it will be 5.5. And similarly here also 5.5. Okay. So if you add up these two, 1.39 is almost 1.4. 4.17 is 4.1 you take up. So 1.4 plus 4.1, it will be 5.4 or 5.49 approximately rough voltage. Because as this one and this branch are in parallel, so voltage must be same. Okay, so here what I wanted to say is calculating the currents, calculating the voltage drops is done by reducing the network. So this is done by network reduction technique. Network reduction technique. So if you want to solve the voltage drop across any branch or otherwise current through any branch, okay, what we are doing, we are calculating total resistance, and then we are calculating total current, and then we are applying current division rule, voltage division rule, or this voltage division rule, current division rule, Ohm's law. We are applying this kind of things, KCL, KVL. Okay, so whatever the basic laws like KCL, KVL, basic rules like current division rule and voltage division rule, we are going to apply on this network, and we are finding out the current or voltage at any particular branch. Okay, now let me show you one more question. Let me show you one more question so that you'll understand. Now find the current flowing through R1 and R2. R1 is here, R2 is here. In the previous network, I have got one source, but in this network, I have got two sources. If you are trying to reduce this network, it is not possible. So network reduction is not possible. Network reduction is not possible. Yes or no? Network reduction is not possible. So what we have to do? Let us apply KCL, KVL. If you are trying to apply KCL or KVL, see, this 2 amperes is going to enter at this junction, and let us apply current division rule. So if you apply current division rule, 2 into opposite resistance 5 divided by 5 plus 10, you cannot apply this one because in this branch only resistor is not there. Along with the resistor, 30 volts voltage source is also there. So what I can say is you cannot apply current division rule. CDR fails. KCL, if you are trying to apply KCL, you cannot apply, other branch currents also not known, so you cannot apply. Is it possible to apply voltage division rule? No. Is it possible to reduce the network? No. Now at this point, when the network has more than one source, and if you are not able to reduce the network, if you fail to reduce the network, then nodal analysis or mesh analysis are required. This is the point. The reason behind nodal analysis, mesh analysis is what? This is the point. Whenever you are not able to apply network reduction technique or current division rule or basic rules and laws, if you fail to minimize the network by network reduction technique, then you must implement nodal analysis, mesh analysis. That is the main thing. What a nodal analysis, then what do you mean by nodal analysis? What do you mean by nodal analysis or mesh analysis? Nodal analysis is not nothing new. Nodal analysis is simply KCL plus Ohm's law. It is just a combination of two laws. Mesh analysis is also KVL plus Ohm's law. So apply KCL and Ohm's law together, apply KVL and Ohm's law together, then it is possible to solve this network. Okay. So I am trying to apply nodal analysis. If I apply nodal analysis, always write the node equations at principal nodes. Principal nodes means at least 3 branches has to be connected. At least 3 branches has to be connected. Now, if I take up this 2 amperes is connected, 10 ohms is connected, and 30 volts is connected. This is principal node, and this is also one more principal node. 2 amperes, 10, and 5 are connected. Out of the principal nodes, select one principal node as ground. Let it be top node or bottom node. It is anything is okay. So I am selecting bottom node as a ground. So this node voltage is going to be 0. Now mention this node voltage as V1. After assigning the node voltages, assume that node voltage is greater than any other voltages in the network and apply KCL. So if this voltage, if V1 is greater than any other voltages in the network, now current always flows from higher potentials to lower potential. So let me assign from this side, let me write it as I1. Let me write this as I2. Let me write this as I3. So if I write KCL, then it will be I1 plus I2 plus I3 is equals to 0. After writing KCL, convert into Ohm's law. If you convert into Ohm's law, if you convert the current into Ohm's law format, that is voltage divided by resistance. I1, we do not have any resistance in this path. We have only current source. And that I1 is opposite to 2 amperes current flow. So therefore I can write minus 2. I2 I can write as potential difference divided by resistance, that is V1 minus 0 divided by 10. V1 minus 0 divided by 10. I3 I can write potential difference divided by resistance, that is V1 minus 30 divided by 5 is equal to 0. So if you solve separately, V1 1 by 10 plus 1 by 5, and the right hand side you will get it as 30 by 5, it will be 6 minus 2, it will be plus 8. Sending on to the right side, it will become plus 8. Of course, this is 0.2 and 0.1, 0.3. So V1 is equals to 80 divided by 3 volts. After getting node voltage, now you can calculate easily current flowing through R1 and R2. What is the current flowing through R1? The current flowing through R1, IR1 is nothing but I2. I2 is nothing but V1 minus 0 divided by 10. So that is 80 by 3 divided by 10. So you will get it as 8 by 3 amperes. Similarly, current flowing through R2, that is equals to I3 V1 minus 30 divided by 5. So that is 80 by 3 minus 30 divided by 5. So if you like this, if you solve, then you will get the answers. I am repeating again, whenever the network consists more than one source, and if you are not able to reduce the network, then you must take the use of KCL plus Ohm's law or KVL plus Ohm's law. This network can also be solved with the help of mesh analysis. The reason behind the nodal and mesh techniques is what? Something has failed, some law has failed, some rule has not implemented. That's the reason why we are coming up with next rule or next method. So what is the reason behind nodal method and mesh method? Because you are not able to reduce the network. We are not able to apply the current division rule. So that point I have mentioned here. So here is the point. One source networks connected in series or parallel can be reduced to simple network. Yes or no? So just now we solved this network. This network can be reduced to 20 volts and with a resistance of 5.53. That's it. And you can solve this network. But this network you cannot do that. However, an interconnection of sources that will not permit the reduction techniques used to find the total resistance and source current. If you have more than one source, definitely there might be chance we may not reduce the network. So in that cases, in that situations, we will implement the methods of analysis that is called nodal analysis or mesh analysis. Okay. So here you can apply nodal analysis or mesh analysis, doesn't matter. Every method has its advantages and drawbacks. So it's like by looking at the problem, if you implement nodal technique, if you get the answer easily, then that's the best thing. If you implement mesh analysis, if you get the answer very quickly, then that's the best method. So you cannot say which method is best. The best method you cannot say, you cannot define. By implementing that method on a particular network, then by using which method you are going to get quick answer, that is the best method. In some cases nodal will be the best, in some cases mesh will be the best. So until unless you solve the network by applying a method, you cannot decide nodal or mesh is the best one. So that is what here this point is about. So I hope it is clear for everyone. If you have any doubts, you can ask me, or else you can write a mail on this mail ID. Okay. So if you have any doubts, you can ask me. Tomorrow we will solve some important model questions on nodal. Very important model, because those are the 3-4 models every time you are going to get. Very important model questions on nodal analysis. Generally they will not ask you to, in the examination they will not ask you to solve the network with nodal analysis. They'll give you the question and they'll ask you to calculate, find the voltage or find the current. So most of the times we will apply nodal analysis. Most of the question, 99.99% of questions can be solved with nodal analysis. It is very rare to get the question on mesh analysis. Okay. So we will see the important questions tomorrow. Chalo then. Thank you so much. Have a nice day.